So, okay. So, when you are solving right triangles, solving a triangle means to find all missing sides and angles. And you can solve a right triangle if you have one side and one acute angle, or if you have two sides. So, on number one, looking at that, we're missing a few things. So we have this side, we have this angle. So we need to find this angle, this side, and this side. So I need to find AB. And I'm going to call AB X. I need to find AC, and I'm going to call that Y. And then I need to find angle A. And I'm going to call that one, I'm just going to leave angle A as it is. I'm not going to label it, but we got to find this angle. So, got to find all three of those things. If I want to find that angle, how could I easily find that angle? 90 minus 48, because those are complementary angles. What's 90 minus 48? 42. So this angle would be 42 degrees. So we've already got one of the three. So now I want to solve for X. And I'm going to use the angle that was given. So I'm going to use this angle. So X, would that be opposite, adjacent, or hypotenuse? Opposite. 8, would that be adjacent? And then Y would be hypotenuse. So if I wanted to solve for X, and if I want to solve for Y, I'm going to have to use this 8, and I'm going to have to use this 48 both times. But solving for X, what would I be using? I have opposite and adjacent. SOA. So I'm going to have SOA for X. So I have tangent of angle 48 equals my opposite X over adjacent 8. And then to solve, I'm going to multiply both sides by 8. And what's 8 times tangent 48? 8.9. So X, or AB, is 8.9. So now we have to solve for Y. So to solve for Y, we are going to use our 8, which is adjacent, and our hypotenuse, which is Y. So if I have A and H, what am I using? Pi. So I'm going to use cosine. So I have cosine of angle 48 equals my adjacent 8 over my hypotenuse Y. Since Y is on the bottom, what do I need to do with Y and cosine? Flip them. Y equals 8 over cosine 48.
11.9.
Yeah, we'll round up to 12. Those would be our answers, right? So, on that problem, we have one angle and one c squared. Gotta use the Pythagorean theorem. So, 5 squared plus 7 squared gives you 74. And then the square root of 74 gives you 8.6. So FD would be 8.6. Okay. Then I found FD, now I need to find angle F, and I need to find angle D. So which one do you want to find first, F or D?
Yeah.
Somebody, F or D? Okay. So we're gonna find angle F. So if we're finding angle F, what would 5 be? Opposite, adjacent, or hypotenuse? Opposite. And then 7, what would it be? Adjacent. So I have opposite and adjacent. So to find angle F, I'm going to use tangent. I'm going to call angle F X. So I'll have tangent of X, because we don't know the angle yet, equals opposite 5 over adjacent 7. I also want to point out, it is important that you actually write tan 48 equals X over 8. Cosine 48 equals X over Y. Don't just write an S or a T or a C. Don't just write 48 8Y. You've got to have this trig function, and you have to have the equal sign in between them. Okay? So it's important to show that work, because if not, I can't give you partial credit if you got like say if you got this upside down, but you got this part right, I could give you partial credit for this, even though that's wrong. So, just so you know, make sure you write everything out like I do. You don't have to write every single step, but I need to see this stuff right here. So if I want to find X, what do I need to do on tangent X equals 5 over 7? How do you get the tangent away from the X?
Multiply. Or you can make it that negative one.
Yeah, that's what I just thought in.
Inverse.
Inverse. So inverse both sides, and I'll have tangent inverse 5 over 7. It's important that you put the trig function on that as well. Like if you were doing this problem and you didn't want to write that first step, you could only write that one and that would be fine. But I need to see some kind of work. So when you put tan inverse of 5 over 7, what is 35.5? So X would equal 35.5. So that's angle F. So angle F is 35.5 degrees. And if you do it the other way, like if you would have done D, you might have got a little bit different answer for your equation. No, you don't get it. But it may be like 1 or 2 decimal points off if you do it one way or the other. But I don't know if I'm going to put one like this one just. I just have to show you. So if you wanna find angle D, what do I need to do with that 35.5?
Can you just do 90 minus 25?
90 minus 35.5. What's that give you?
54.5.
54.5. So do the easiest one first. So how would I find angle I?
90 minus 41.
90 minus 41. Since we already have one of the acute angles, we can just subtract that from 90 to get angle I. That'll give you 49. Okay. Now, using that angle and this side both times, we will solve for x and we'll solve for y. So, x, looking at angle 41, would that be opposite, adjacent, or hypotenuse? Adjacent. Y, opposite or hypotenuse? Hypotenuse, and then 14 would be the opposite. So, if I want to solve for x, I have adjacent and opposite. What am I going to use? So I'll have tangent of 41 equals my opposite 14 over adjacent x. Because x is on the bottom, what do I need to do with both those?
Put it like a fraction.
Flip them so that it's in a fraction. So x equals 14 over tangent of 41. What would x? 16.9. Now that I found x, gotta solve for y. So, looking at my 41, I have opposite and hypotenuse. So I'm going to use sine. So we'll have sine of 41 equals opposite 14 over hypotenuse y.
Why is the opposite 14?
The opposite. So I was just saying opposite over hypotenuse. Opposite, which is 14,
Oh,
over hypotenuse, which is y. Okay, so since y is on the bottom, we gotta switch the place of the sine and the y. So we'll have y equals 14 over sine 41. You should get what? 21.3. more and we'll be done with this stuff for now, like, we'll be done with it. I'm not gonna do page 19. If you did do page 19, you can check your answers. Okay? So if I am trying to solve this triangle, I've got to find side KL. I've got to find angle J. And I've got to find angle L. Those are my three things I'm trying to find. So if I want to find KL, I'm going to have to use Pythagorean theorem. So I'm going to use Pythagorean theorem. Is KL the hypotenuse? No, it's just a side. So I'm going to call it A. And then what would my hypotenuse be?
22.
22. So I'm going to have side squared plus side squared equals hypotenuse squared. So A squared plus 18 squared equals my hypotenuse 22 squared. So to solve, I'm going to subtract 18 squared from both sides. A squared equals 160.
Yeah.
Square root both sides. And what would A equal? 12.6. The KL is 12.6. So now I have that side. I can solve for angle J or angle L, doesn't really matter which one. So angle J or angle L? J. So if we solve for angle J, we gotta use 18 and 22. I'm gonna call that angle F. So 18, would that be opposite adjacent or hypotenuse? Adjacent, and then 22, opposite adjacent or hypotenuse? Hypotenuse. So I've got adjacent and hypotenuse, so I'm gonna use cosine. So to find that angle, gotta do cosine inverse of adjacent over hypotenuse. So 18 over 22. Cosine inverse 18 over 22. What do you get? 35.1 degrees.
Minus 95.
And then to find angle K, you will do 90 minus angle K, angle L. 90 minus 35.1. That'll give you 54.9. Okay, so we're gonna skip page 19, we're gonna skip page 20, and we're gonna skip page 21.
might as well just get the whole book. I have a question. On number 2, when you say degree, you have to divide 360 divided by 5.
Okay. So what page are we on? Page 22.
If you would, scroll back on the first one.
What?
If you would, scroll back on the first one.
Okay. So with sine and cosine, when you're looking at applications, there are two different types of angles that you might see. And one's an angle of elevation and one's an angle of depression. So what that is if it's an angle of depression, it's like somebody's eyesight and then they look up, so the angle elevates. When it depresses, it's like their eyesight and they look down. So based on what it tells you, you're gonna have to decide where the angle goes based on if they're telling you they look down, if they elevate, or if they look up and elevate, or if they look down and it is a depression. So, looking at number 1, just gonna read through these and go through them. Hopefully, by the end of today, you'll understand a little bit better how to do these. But Casey sights the top of an 84-foot tall lighthouse at an angle of elevation of 58 degrees. If Casey is 6 feet tall, how far is he standing from the base of the lighthouse? So, what we're doing here, the picture is actually up here in the top part, but I'm going to draw another picture just so I can show you how I normally do this. So it tells you you have Casey. Here's Casey. It tells you that Casey's 6 feet tall. You know Casey's 6 feet. It tells you that he is looking at a lighthouse. So you know he's looking at a lighthouse. I just draw a little picture. So there's my lighthouse. Yeah, these extras I have. But he's looking at the lighthouse, right? So there's his line of sight. Okay. And he's looking to. That's not his line of sight. That's his original line of sight, and then his new line of sight looks to the top of the lighthouse. Okay. So here's our triangle. Not perfect, but whatever. So now I have my picture drawn. I'm gonna go back and make sure I have everything. So it says the lighthouse is 84 feet tall. So the whole lighthouse is 84 feet tall. Casey 6 feet. The angle of elevation from his original line of sight to the top is 58 degrees. So this right here as it elevates would be 58 degrees. It wants to know how far he's standing from the base of the lighthouse. So that would be the distance from him to the lighthouse. So now our picture is fully drawn. We just got to find one thing. Okay? We're focusing on that triangle. We're just using the little stick figure in the lighthouse to help us find something. So, it tells me that he is 6 feet tall and that this whole lighthouse is 84 feet tall.
84 minus
In
6.
order to find this triangle, we have to know this little part. So we're going to do 84 minus 6 to see the difference between him and his line of sight with the lighthouse. So 84 minus 6 is 78. So this side is 78. I know it's inside, but I don't have room outside to draw it. So there's my picture right now. So basically, now that I did all that extra stuff, this is all I really need.
Wait, why did we do 84 minus 6?
So we did 84 minus 6 because we need this part of the lighthouse, but we don't need this part. And that part is his 6 feet. So that's how we got that 78. So basically, all we needed or need now is just this triangle part. You don't have to redraw it. I just did that because it's easy for me to copy and paste on my iPad. So now that I have the picture drawn, now you can solve it like normal. Drawing the picture is the hardest part, and labeling the picture is the hardest part. I'm probably going to draw the picture for you, and then you just have to label everything on. So, looking at this triangle, or you can, look at your original. I'm trying to find x, and my angle is 58. Is 78 opposite, adjacent, or hypotenuse? To angle 58. It's opposite. And then x would be the adjacent. So I have O and A. What am I going to use to solve? TOA. So I'm going to have tangent of angle 58 equals my opposite 78 over adjacent x. I promise you they're not all as bad as what that one might seem like. I just had a really hard time explaining that. I don't really know why. But now switch the place of the x and the tangent. So I have 78 over tangent 58. The 48.7 feet. That's how far that Casey is standing from the lighthouse. Okay. Number 2 says the angle of elevation from a kicker's foot on the football field to the top of the goalpost is 17 degrees. If he's standing 131 feet from the base of the goalpost, how tall is the goalpost? So, I'm just going to draw a right triangle. Not going to be perfect, just drawing a right triangle. And I'm going to say this is the kicker's foot right here. So that's the foot. This is the ground. Then I'm going to say that is the goalpost. So now I'm just going to label with what they gave us. So there's my basic picture. Just going to label it with the information they gave us. So they gave us 17 degrees. And it says from the foot on the football field to the top of the goalpost. So foot on the football field to the top of the goalpost would be this angle right here. Would be 17 degrees. And then if the kicker is standing 131 feet from the base of the goalpost, is that going to be the bottom or the side?
The bottom.
The bottom. That's the goalpost. We're looking at the bottom. We're looking for the distance between the kicker and the goalpost. A lot of y'all messed that up on the worksheet yesterday. The base is always going to be the bottom. So that would be 131. And then we want to find how tall the goalpost is. So not the hypotenuse, but the goalpost. So yeah, it will be opposite. So x would be opposite. 131 would be adjacent. So since I have opposite and adjacent, gotta use tangent. So tangent of angle 17 equals the opposite, which is x, over the adjacent, which is 131. So what do I need to do to both sides?
Multiply by 131.
Multiply both sides by 131. One 31 times tangent of 17. 40.1 feet. Okay, so I'm just gonna go ahead and draw my little right triangle on the next one. And then from that, I'm just going to see what I need to label. So it says, Leah's mom is standing at the bottom of the slide at the playground, waiting for Leah to slide down. If the angle of elevation from the bottom of the slide to the top is 46, and the slide has a vertical height of 9 feet, find the length of the slide. So, imagine this is a slide. So this will be the ladder, that would be the actual slide. So that's what I'm going to label it, is the slide, and then this will be the height, which will be the ladder of the slide. And then obviously the bottom of the ground. So, now that I have my picture and I know what the sides of my triangles are, now I can label them. So it says we have an angle of elevation from the bottom of the slide to the top. The bottom of the slide to the top would be right here. So that's my angle of elevation. So that's going to be 46. And then it tells me it has a vertical height of 9. So my height, how tall it is going to go on this side. And then if it wants to know the length of the slide, is it going to be the hypotenuse or is it going to be this side? Hypotenuse, because that's the actual slide. So that is what we're going to call it. So now, looking at our angle 46, 9, is that opposite, adjacent, or hypotenuse? Opposite. And then x, adjacent or hypotenuse? Hypotenuse. So I have O and H. What am I going to use? Sine. So I have sine of angle 46 equals opposite 9 over hypotenuse x.
0.5.
So to solve for x, you got to switch the place of the x and the sine. And when you plug that in, you'll get your answer. It'll be 12.5 feet. before when I drew my right triangle. So a dog is standing 5 feet from the base of a tree, looking up at a cat that has climbed 16 feet up into the tree. What is the angle of elevation from the point the dog is standing in the ground to the cat? So here's the ground. This will be the tree. Here's the cat at the top. Here's the dog at the bottom. So it tells you the dog is 5 feet from the base of the tree. So would that be the ground, the tree, or the blank side?
Ground.
The ground. And then it says the cat is 16 feet up in the tree. So would that be the tree or the blank side? Tree. And then it says it wants you to find the angle of elevation from the point on the ground that the dog is at to the top, which is the cat. So here's my angle of elevation. So from the dog to the cat. That's what I'm trying to find. You can label that any variable you want. Because a lot of people don't really like the theta, I'm just going to call it x. If you want to use theta, you can. But now the whole picture is labeled and you can solve it like normal. So this is my angle 5. Is that opposite, adjacent, or hypotenuse? Adjacent. 16, opposite or hypotenuse? So I have O and A. I'm going to use tangent. So I'm going to have an inverse, right? Because I'm looking for an angle. So I'm going to have tangent inverse of opposite 16 over adjacent 5. So it's tangent inverse of 16 over 5. 72.6 degrees. Okay, so that's angle of elevation. Now we're going to look at angle of depression. So, if you flip over to page 23, you can kind of see it a little bit with this, how you have a triangle, and then you have this dashed line on it. So what's formed right there from the dashed line to the triangle is the angle of depression, and the dashed line and the bottom line are parallel. So, we're going to use the fact that they're parallel to our advantage, just so you know. So, angle of depression, remember, is just a straight line and then looking down. So I'm going to draw my triangle. Doesn't matter, you can draw your triangle facing that way, you can draw it facing the other way. It doesn't matter how you draw your triangle, it's just your picture. But there's my triangle. And then here's my line of sight. Not line of sight, there's my line that I'm going to use to find the angle of depression. So basically, anytime I see that, you're going to have the little dotted line. So, The lifeguard is sitting on the platform.
Christian Cumbus to the office. Christian Cumbus to the office.
So the lifeguard is sitting on top of the platform looking down at a swimmer. So here's the lifeguard. And he's looking down at a swimmer. So the swimmer's down here. So this is his platform. Okay. So if the lifeguard's line of sight is 8 feet above the ground, and the angle of depression to the swimmer is 18 degrees, how far away is the swimmer from the lifeguard? So, if it says the height of the lifeguard, the line of sight starts 8 feet up, the vertical height would be 8 feet. It says the angle of depression of the lifeguard's line of sight to the swimmer would be 18 degrees. And then it wants to know how far away the swimmer is from the lifeguard. So if you want to know the distance between point A to point B, are you finding the horizontal, not horizontal, are you finding the diagonal part or are you finding the horizontal part? The bottom or the line of sight?
The bottom.
The bottom. Because it just wants to know, if there was one more word in there, it'd be a little bit easier. How far is the swimmer from the base of the lifeguard's platform? Would make a little more sense about what it was asking for. That is what it's asking for though. It's from the swimmer to the base of the lifeguard's swim. So that's what it's trying to find. So now, like I said just a second ago, these lines are parallel. Okay? Line of sight is always parallel to the ground. So when you're looking straight ahead, your line of sight is parallel to the ground. So if those two lines are parallel, what do you know about this angle right here and this angle right here? They're the same because they're alternate interior. So that angle would be 18 because of alternate interior. So now, since we know that angle, what would 8 be to angle 18 inside the triangle? Opposite adjacent or hypotenuse? Opposite. And then x would be adjacent. Since I have O and A, I'm going to use tangent. Tangent of angle 18 equals opposite 8 over adjacent x. Since x is on the bottom, got to switch the place of the tan and the x. Eight over tangent of 18. triangle. Gonna have my line of sight. So, a pilot in a helicopter spots a landing pad below. If the angle of depression is 73 degrees and the horizontal distance of the pad is distance to the pad is 1,200 feet, what is the altitude of the helicopter? So, we're thinking about this bottom being the ground. Then we know here's the ground. If that's the ground, where would the helicopter be? Would it be on the ground or would it be in the sky? In the sky. So here's the helicopter. So it says the angle of depression from the helicopter to the ground is 73 degrees. So that's 73. So if that's 73, what do we know the angle inside the bottom is? 73. Because of alternate interior. Then it says the horizontal distance from the landing pad to the helicopter is 1,200 feet. So the landing pad's going to be out front. That's where the helicopter's trying to go, to the landing pad. So the distance, horizontal distance from the helicopter to the landing pad would be 1,200. It wants the horizontal distance. That's how you know where to put that, because it says horizontal distance. You want the horizontal line, not the diagonal. So you got vertical, diagonal, horizontal. So 1,200 would go on horizontal. And then it wants to know the altitude of the helicopter. So remember, altitude is the same as height. So would I want the hypotenuse or would I want this side over there?
Over there.
Over there. So we're trying to find that. That's our altitude. So looking at our angle 73, x would be opposite, 1,200 would be adjacent. So we're going to use tangent. The tan of 73 equals opposite x over adjacent 1,200. So, multiply both sides by 1,200. 1,200 times tan 73.
3,925.
So 3,925. How high that helicopter is. Okay, the next one is a little bit trickier. It's kind of like that lighthouse one where you have two different. What do you think? Okay. So now I need to find x. Here's my angle. X will be adjacent. 174 will be opposite. So again, I'm using tangent. You do use tangent quite a lot with these kind of problems. So tangent of 42 equals opposite, which is 174, over adjacent, which is x. So x is on bottom, gotta switch them. 5x equals 174 over tangent of 42. So what would x equal? 193.2.
I am just one and one. Yeah, when I'm,
193.2 feet. Okay. Last one for this page.
how many are we doing?
The last one on this page.
Like, how many of the problems?
This is basically the end of angle, depression, and elevation. Basically. You'll see a little bit more later on in practice, but we're gonna just go regular-ish word problems. Okay, so here's our triangle. We've got our line of sight right here. We're looking at angle of depression. So it says Zach is standing at the top of a lookout tower. So if Zach's at the top of the tower, there's Zach. And spots a water fountain below. So down near the bottom, that would be the water fountain. That's his line of sight looking at the water fountain. If the lookout tower is 75 feet tall, so if the lookout tower is 75 feet tall, this would be 75. That's the lookout tower. And the angle of depression is 28. So this is 28. So this one's 28. What is the horizontal distance between that and the water fountain? Since it's horizontal, it's going to be the bottom. It's going to be that base. Now from our picture, we can just pretty much ignore the word column. We're just going to look at the picture. So there's my angle. 75 would be opposite. X would be adjacent. Got to use tangent. So tangent of 28 equals the opposite, which is 75, over the adjacent, which is the x. Switch the place of the x and the tangent. And plug that in the equation.
141.1.
Will he can.
Okay? Number 3. Just gonna draw me a triangle. So a 100-foot tall building has a wire that stretches from the roof to the ground. So if I'm looking at a building with a wire, I'm gonna have, this is my building over here. This would be the wire.
200.
So the building would be 100, the wire would be 200. And then this will be the ground. It wants to know what is the measure of the angle that that wire makes with the ground. So that's what I'm trying to find right there, is that angle.
You use time. What? Time.
So you would have opposite and hypotenuse, so you will use sine. And since we're looking at an angle, trying to find an angle, we'll use the inverse. So I have x equals sine inverse of 100 over 200. 30. Okay, so remember, I said it earlier, but make sure you write S-I-N. Don't just write a S, a T, or a C. You can do that with the first little part, a little trick, but don't use it when you're showing your work. And make sure you actually do show those parts. Show the sine 30 equals 12 over x. Show the sine inverse of 10 over 20. I mean, 100 over 200. Okay, so a ramp rises 4 feet and makes a 20-degree angle with the ground. So that's my ramp right there. So it's 4 feet in the air, 20-degree angle with the ground. How long is the ramp? If you're trying to find the length of the ramp, you're trying to find that hypotenuse. What?
Oh, duh.
So you have opposite and hypotenuse, so you use sine. So sine of angle 20 equals opposite 4 over hypotenuse x. Switch the x and the sine. And then plug that into the calculator. I'm gonna, just if you're working ahead, I'm gonna skip the next page, just in case you're wondering. I'm gonna skip page 25. But if you wanna know the answers, you can always check it. And I'm gonna draw the pictures for 5 and 8. So I drew the pictures, now you label them, you solve them.